Okay, so today we are continuing shapes of covalent molecules. It's also called molecular shape. Our exam is on Friday. Tutoring is available during your lunch, after school, and before school. Just let me know when you're coming in case you need a pass. Okay, after the instructions, you may work with your elbow partner. In order to complete this lab, you're going to need this worksheet. Everyone should have one on your table. If you do not have one on your table, there's one in the very center on the table in front of the classroom. You're also going to need these. This is going to help us see the shapes better. If you need any extra colors of molecules, there's a box of molecules up here on my desk, and feel free to grab one. So covalent bond is a nonmetal and a nonmetal. If you want, you can write that. Okay, so this is a very fundamental piece because if you are not able to identify yet if it's an ionic bond or if it's a covalent bond, then we won't be able to do these worksheets. So on your periodic table, this is just a reminder, over here on the right side, these are your nonmetals. It's a very small portion of the periodic table. If two nonmetals are together, then it's considered a covalent bond, and that's what we're going to be practicing today. Does the type of chemical bond that will form between two atoms can be predicted by calculating the difference in atoms of electronegativities. So the difference of electronegativities, that's when this comes in, because you're going to subtract. That's what difference means. So these numbers is the strength of that particular atom's electronegativity. Electronegativity means it's the affinity for an electron, like how strong is it to take electrons or share electrons, or vice versa, how weak is it? When the values of two atoms' electronegativities are far apart, one atom loses one or more electrons to the other, and that's considered ionic, because ionic is the stealing or transfer of electron. So one of the elements has to be very, very strong. When two atoms of electronegativities are closer in value, the atoms share electrons, and when you share, that's called covalent. Covalent bonds are considered nonpolar when atoms' electronegativities are nearly the same and the electrons are shared evenly. So we did practice this a little bit yesterday. I'm going to skip down to the bottom. The procedure. This is what we're doing for every element. We're going to construct the electron dot Lewis structure for every molecule. So this one, if you just want to write right here, valence electrons. Because we can't do the Lewis dot structure without knowing the valence electrons. Okay, if you're not sure what valence electrons are, here's my messy periodic table. They're the numbers in purple, if you want to write them down on yours. So everything in this family, 3 valence electrons, 4, 5, 6, 7, 8 valence on the very last. On this side, this whole family has 1 valence electrons, and then the alkali earth metals has 2 valence electrons. Okay, the valence electrons represents how many dots are going to go on these structures, because it's what's the outer electrons. And the outer electrons are the ones that you can actually share or you can steal. So let's start with H2. Okay, the electron dot structure. We have 2 hydrogens. Can anyone tell me what the valence electron is for hydrogen by looking at your periodic table? Autumn? 1. So each hydrogen atom can give 1, okay? And by doing that, they just created a bond. Okay? The shape of the molecule. Are there any lone pairs in this? Do we see any 2 that are just left alone? No. So what do we think this shape would be? I mean, you could use your molecules. So I just have 2 hydrogens. And that's my shape. If you forgot what shapes are, you need a little refresher, you can grab your paper. the one that's on every desk, and these are the shapes. The ones that we've covered so far is linear, tetrahedral, trigonal, pyramid, and bent. So you can always refer back to the sheet. Looking at this molecule, what would we say the shape is? Linear, good job. Calculate the electronegativity difference. That's when we're going to go to this worksheet. Hydrogen is right here. Everyone find it on your paper in front of you, hydrogen. Okay, and it's 2.1. So we're going to subtract. So H is 2.1. The other molecule in this question was 2.1, and we're subtracting them. So it gives me 0. And this is the scale I'm using right here to figure out if it's polar or non-polar. If it's less than 0.5, it's polar. So what is this molecule? Because it is less than 0.5, right? It's 0. So you would just write polar.
It's non-polar.
Oh, I'm sorry. You're very right. Non-polar. Thank you. Okay, so it's non-polar. And then this section right here, I'm just going to remind myself, this is the tug of war question. And this is for you to visually see if one of these elements was stronger, okay, would it completely win? So since these are non-polar, they both have the same values, okay, so there's no net gain, you would just say it's a tie. If one of them is stronger, then that's the molecule that's going to win, and you would write win. Okay, let's do F2. Anybody have questions on how we did that first one? Okay, if you feel comfortable doing this, you can continue on and, you know, go through the worksheet. This is a lab grade. You can work with your elbow partner. Okay, so F2, there's 2 Fs. Go ahead and draw your 2 Fs. Can anyone tell me the valence electrons? 7. Okay, let me show you how you found that. For fluorine, it's right here. And the valence for this family is 7. So each fluorine gets 7 dots. You can just start drawing them. When there's 2 electrons right by each other, that creates a bond. Okay, so they're bonded. And both of these atoms are stable. Okay, that's one thing to remember when you're putting dots, that all elements want 8 dots around it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. And they can share. Hydrogen is the only one that needs 2, so that's why this one up here is stable. It's happy, it has its 2. So being hydrogen, or the 2 fluorines, which is similar to the 2 hydrogens above, do we have any lone pairs or anything kind of left out? No. So it's just going to be, the shape is linear again. And if you guys want, you can put the degrees, 180 degrees. And I'm getting this from this chart right here. It says linear, and the angles between the bonding pairs, 180 degrees. So I'm going to find the electronegativity difference. So for fluorine, 0 minus 4.0. Okay, and this gives me 0 again. I found this electronegativity number where F is right there on the top right hand corner on the paper in front of you. Again, is this going to be polar or non-polar? nonpolar. And this is going to be a tie. I want you to take a minute and talk to the person you're sitting right next to, okay? And discuss between you two, what if one of them was really, really strong and took an electron? Is that still a covalent bond? Okay, so discuss between each other if it would still be a covalent bond. Okay, so you guys should be asking each other, if something steals an electron, is it considered covalent? No? What kind of bond would it be if it's so strong, if the electronegativity is so strong it can take it? It's an ionic bond. So are we going to see a lot of nonpolar? Probably. Okay? There will be some polar, but that's just something to, visually understand that covalent is sharing. Okay? So we'll continue the worksheet. At the very end, there is some practice of naming. If you can flip to the back. I just want to do one or two with these, because we needed some practice to name covalent. At the very top, you can use Greek prefixes. If you forgot them, I'll go ahead and I'll put them on the screen. So number 1, AS, you look at your periodic table and you find that it's arsenic, but you write tetra arsenic. You probably don't put 2 A's. And then 10 is deca, so deca oxide. Tetra arsenic, deca oxide, because of these little subscripts. Br, you don't put mono if it's the first element. You only use mono on the second one. So Br is just going to be bromine. And what's the prefix for this little number 3? Yeah, so trioxide. I'm going to be walking around if you guys need some help. Again, you can work and ask somebody who's right by you.